Hello, my name is Miłosz. I'm a software developer in Oke, Poland. Currently I'm working for multiple customers as AI consultant, machine learning consultant with Stream Group in a product that is detecting commercials from Stream in real time. In Oke internal product Chamberlain that is home automation with real-time AI that is processing face, silhouette, and detecting faults. Also, I'm a performance tester in C-Change, so yeah, that's also one of my specialties, performance. So that's one of the subjects I will touch today. Mobile device as a gate to machine learning world. So how to utilize your mobile device in data flow of systems using machine learning. We have a natural order of miniaturization. So first, when you are developing some new product, I think you need lots of computation in AI area, so that's natural that you use a custom supercomputer. After this, we move to cloud, like Azure, like Amazon and things like this. Then we miniaturize our supercomputers as embedded, and now we are at final stage of our evolution. So we are going mobile. So this is quite funny because I was very against this idea to go with AI to mobile. And actually, I thought that it is almost impossible to create deep learning models on mobile phones. So I was very surprised when I saw some recent Apple achievements and Tensorflow Lite achievements. Of course, this is not so great that it sounds like. Because if you would like to generate quite nice and accurate AI models, you still need to rely on cloud or custom supercomputers. So why I need machine learning on my mobile? So machine learning, what is machine learning in this case? Because currently we are using machine learning in multiple areas. So for example, like previous speaker said, for high frequency trading, those things are done cloud or on supercomputers. For image processing, like face recognition, face detection, some actions detection, they are currently weak AI, because this is AI which is working for us, not strong AI which has self-consciousness. It's currently used mostly to track us and spy us. So the main reason why you would like to keep your machine learning data on your phone is because the data are currency now. So they are very precious. And you don't want to give your data to external providers. Of course, there are multiple other things that could improve your data flow with machine learning when you move to mobile. Of course, you are able to save some internet connection limit on your customer device, but incoming 5G internet, so this won't be a problem anymore probably. But for example, in Netherlands, there are still people using 10 megabits internet connection. So this is still problem, not in low developed countries, but in very developed countries like Netherlands. So you also would like to be independent from internet connection, because if you have some system that is quite important for you, so it is solving some very important problem, like some healthcare or monitoring your overall condition, you would like to not lose it when the internet stops. So if your machine learning algorithm is, for example, monitoring your heart rate because you are after a stroke or something like this, you don't want to lose this functionality when the internet is stopped. Of course, there's the biggest reasons why you would like to move machine learning to mobiles. Money. This is the main reason, because cloud processing is very expensive. So, for example, Amazon instance with Volta 100, which is able to process 6,000 frames per second on ResNet 50 model, it can cost up to $50 per day. So this is 30,000, more than 30,000 per year. So this is quite expensive thing, and 6,000 frames is really small amount. So you probably would like to move this to your client device. It also solves scaling problem. The problem that currently mostly hitting most of blockchain technology, scaling, because too many people want to do too many things on the same infrastructure. This is applicable also here. So your machine learning models are strictly stick to what machine you have in cloud, or you need to buy more computational power. 2 years ago, most of those technology was unreachable, because computational power was so expensive that most of those algorithms was way too. The cost to benefits was not good. So it was quite not good technology then. You would wonder what can you do on your mobile, and when I was working on this problem a few weeks ago, I was very surprised, because you can use any model. Of course, there are some limitations. For example, ResNet it's not maybe impossible, but I strongly recommend to not use higher ResNet with more layers than 50, because it's quite slow then. All inception models works quite well, and there are multiple architectures that works very good with mobile. They are optimized strictly for mobiles. Squeeze nets, shuffle nets, mobile nets, all of those needs less than 1 GFLOPS to operate. So this is executable even on older phones. Of course, those are for pattern recognition. Currently on your phones already working some sequence and multi-class classification, scalar regression, and all other statistics methods, because those statistics methods is nothing new. This technology was here even before mobile phones, and they are quite easy to process. This is standard statistics, so but yeah, machine learning is about statistics, so in this matter. There's nothing new. There are random forests which some of you probably, if working with machine learning, faced and found out that they are way better than neural networks. But I'm not a big fan of this because they are used to overfit. So, of course, for sequence, there are multiple networks. Most of them are recurrent. Also, I place these hidden Markov models, which is very old technology. Probably some of you on university was using a product called Sphinx, which is a speech recognition system. It's quite old, but it's very functional. We use this in our product, in our Chamberlain product, because this is quite nice neural network to detect some commands, and it takes very small amount of resources. So Raspberry Pi can run this and run all our system in the meantime. So it's quite useful, but it is very limited. It also works with mobiles. There is also nothing new, nothing innovative. Thing that is innovative in this matter is that mobiles can run now multiple GFlops processing power. What is the biggest fear in mobile machine learning? Well, maybe I will start. What is machine learning on mobiles? Because lots of you think machine learning and think that mobile phones actually produce models. No, they don't produce models. In very rare exceptions, like Apple Face ID and fingerprint processing, those are exceptions, and they are really genius technology, but all the other are processed outside your phone, and probably won't be produced, won't be trained on your phone for a while, because if some of you try to execute some training scripts, would know that it requires lots of time, lots of resources, and mobile won't reach this, I think, next 10 or 20 years. So what is our biggest fear here? That's true that machine learning systems usually are associated with large expensive GPUs. I'm talking here about neural networks mostly, because this is the area I'm working with most. And yes, this is very hard to train some model with CPUs. Geniuses from Intel trying hard with MKL library, but I'm not sure they will succeed soon, or they will change architecture of processors. And there is one more problem. Most of our mobile devices using battery. So yeah, this is unbreachable wall probably forever. Also, a bit about processing, about response times of inference model, because the inference is actually what we are executing on our phones. This is not. This is relation like teacher-student. You are not teaching your model. You are just using the knowledge of the student on your phone. And even those are quite slow. So, for example, if the same model executes on Volta 101 millisecond, the same model, like Inception V3, will execute 120 milliseconds on iPhone X. So this is quite slow. Some of you will think that it's way better to execute, to build script with multiple of ifs, because I've heard multiple times that machine learning is only a couple of ifs. Yes, or not, or maybe. Actually, this is not so simple, but if we would like to generalize this, yes, it is a couple of ifs. But this is an example how to use machine learning just to short your work time. I use the same time to produce model using long short-term memory algorithm, which was trained over the data from OpenPose and Coco train set. And I spent the same amount of time to produce algorithm detecting faults. So if you are falling down, the algorithm is taking data from OpenPose from OpenPose matrix and detecting if you have fallen on the floor or not. These are real results. So my spaghetti code, which I spent over 8 hours, is 540 lines plus, because it is not finished yet. And LSTM, which has only 10 lines, was training 8 hours. So in this case, we reached higher accuracy using machine learning than spaghetti code. Of course, you can combine this. It's quite nice solution, but still it's very slow. It runs only 6 frames per second, so it's very slow. It was running on an embedded system. It was running on NVIDIA TK1. It is comparable to phones, but it contains GPU that we can use. So, yeah. As I said, mobile devices has multiple limitations. This is a huge problem in this area. I think it won't be solved for a while, because when you are trying to produce some models, to use them, you need to keep in your head that it is disabled. So a bit. Maybe it's quite not nice word for this, but it is very limited. For example, a normal inception model with 1000 classes is up to 200 megabytes, and this is relatively small for deep learning model in image processing in this case. So limiting the number of classes is one of approaches that allows you to run this on mobile, but still it also causes that you won't be able to do whatever you want. Also, you can't process large batches of data because your GPU in your phone is not strong enough. If you would try to process, for example, batch of 16 images on your phone, it would take few or even more seconds, or even you will reach out of memory exception. This is quite often, because of this you are able to process one image at a time, not like on embedded systems. For example, on NVIDIA TX2 you can process 1632 images at one time in one batch, and the processing time is less than 20 milliseconds, when on your phone you are able only just to process one image, and with 5, 6 or even 10 longer time. So yeah, this is still a big problem. When you are trying to use your mobile to execute deep learning models, you have, usually you are using optimized models. So, for example, SqueezeNet or ShuffleNet. They are quite nice, sure, but they are able to be trained up to maybe, I don't know, 90%. This is max I was able to train, and after this there is nothing, and probably this is causing that you won't rely on your model totally, because if your product fails once on 10 execution, who would use it? Probably, everyone would be upset, because you are, for example, scanning your Mac and your algorithm says it's computer. Nope. There's nothing to and it's quite hard to improve this, because those optimized models are as they is. So the only way is to increase computational power and use better models. In this case, I'm still talking about image processing, because as I said, there are multiple other algorithms that are running on your phone all the time. All are regression. When you are typing your text, they're different. You have some memory in your memory of words which you executed some time ago. This is old technology, because your phones are learning yourself. So these are regression models that was used a while ago and was developed years before first machine learning framework was created. So that's the machine learning that you can rely on your phone, and there is no innovation. Of course, you would be able to produce some models that you could use. For example, Inception File 3 could reach even 97% of accuracy, but still it requires lots of time and resources to produce such models. So in this area, I think this technology is still too young to be used for video processing, and it's quite used for a long time in other areas. So even I heard last time that some company was able to implement WaveNet, Google WaveNet, on local device. This is huge step forward, because for now, if someone of you was using deep speech API of Google, would know that it was going through the whole crowd processing, and it was a bit inaccurate, but it works well. Yeah. So implementing those outside cloud locally is really huge. It's really huge step forward. What devices can I use? Which devices would work with my AI? For iOS, you could check which devices support ML Core, or in future ML Core 2, because Apple created their own framework to work with AI. This is quite nice. They give you some nice API. They give you set of tools. They give you Face ID, which is genius. But there is a hack in Face ID that you probably, if you would try to implement this on, for example, Samsung or Xiaomi or whatever, you will fail, because they are using depth camera to build your model. So that's why they are able to train your model on phone because of simple hack. They are using a fourth dimension, so your face is unique enough to do only a few iterations over. In iOS, it is simple. For older versions, I would recommend to use Tensorflow Lite. So it is possible, but they officially does not support ML Core. But in Android, there is no simple solution, because each time you need to profile your model. This is very complicated, because profiling model is running actually a specific tool in TensorFlow Lite and calculating how much GFlops it needs. It can be extrapolated quite easily with linear extrapolation, so you could do this. So, which framework? There is no ML Core, because ML Core is not machine learning framework. This is only a framework for execution, so it only consumes model. They don't have their own training API. I won't go over all frameworks, because this is subject for two different prelections. I will stay with Keras and TensorFlow, because they give you most tools to process over iOS and Android. And the next reason is because they have most contributors on GitHub. They have a few times more than MXNet and Gluon. How to plan your training workflow? This is very funny thing, because a while ago I was talking with someone from Amazon that was working on Alexa. And did you know that they are listing random things from Alexa, and they are retraining model with manually validated data. So this is they are actually hearing what you are talking to your Alexa, and probably there is something. This is something inside your rights, which you are setting when you are buying product. But yeah, there are a few steps that you need to keep. You need to keep in mind that iterative collecting data from mobiles and retraining your model is the only way that your model will provide any accuracy than 80, 70, 60%. There's quite nice API in TensorFlow that allows to run your model on mobile. You can freeze your graph, so you are making variables to constants and optimize for inference. So you are removing from your model some redundant layers that are used only for training. This is very useful and very nice, because it can improve your performance even 70%. And here is the reason why I recommended to use Keras and TensorFlow, because those two frameworks are compatible in both systems. I'm not including Windows Phone, because they don't support anything officially. So Keras is importable via iOS very easy way. You're just loading to ML Core Keras model, so there is not much work in theory. but sometimes there are unsupported layers, so you need to still convert this to original TensorFlow model, the TensorFlow Lite model using freeze and optimize, and then with the OCO tool. In theory, it sounds great. It sounds easy and it sounds like a fun, but the reality is quite disappointing. When you are trying to convert your models, especially when they are custom models, you need to prepare yourself to fail a few times at least, because this is still very young technology, and this is technology full of bugs and still many unsupported operations. And what are our results? Low accuracy, battery draining, first kernel allocation, which can take, if your model is huge, it can take even few seconds. It eats all your RAM from your device, and your expectations fail very badly. So yeah, at this way, I'm not very happy with using this technology. But the testers are happy because they can test and they can live their adventure. This is a very nice catch for your team, because when you will say someone that hey, you are going to write very boring tests for my application, okay, I'll do this. Hey, you are going to train artificial intelligence, yeah, and this is what they feel. They feel adventure. So yeah, until they train your model first time, after this it will be harder to motivate them, but yeah, you would have some nice trained model, because this process takes lots of time, many iterations. And so, as I said, I'm also a performance tester, so this is one of my main areas. So, how about performance? I'm comparing to NVIDIA SBC TX2 because it is size of a mobile device, like your iPhone or something like this, and yeah, those times are even not close to custom crafted SBC for machine learning. Even on paper, iPhone X claims that they have 500 GFLOPS processing power. Maybe, I'm not sure about this. SBC NVIDIA TX2 has 1.5 teraflops, but still it should be linear, but still it isn't. So, how we should treat this technology? For now, I think you shouldn't depend on this. So developing products with this technology is too young, in my opinion. So it should be treated as a younger system. So only for simple tasks. For example, you can collect some data from phone to build real-time processing face recognition from CCTV in home automation, like we did in Chamberlain. This saves lots of time. Also, building such systems is quite hard, because I don't know if you know that CCTV face recognition system in Great Britain is only 6% accuracy. So they are searching for convicts in this, but yeah, this is only 6% and 94% of fails. So collecting those data is quite a nice usage. I was looking for true value where the image processing, where this technology can be used, where their fails can can be forgiven and where it can really produce quite nice product, and it is augmented reality. This is really thing that I think this technology fits for now, because in the future when it will be more reliable, I think it will be applicable to more areas. But for now, developing such product like scanning some things in shop, printing some promotions and things like this, I think that's target real value of this technology. Also in games, of course, there is at least one framework that I'm aware of that is starting to using machine learning with augmented reality. Yeah, this is quite a good idea. So, what is conclusion? I think we should stick in product development if we would like to have some nice AI product, custom crafted for a customer, for example, smart city or home automation or self-driving cars, or even just helping driving cars. I think we should rely still on a bit older. We need to take a step back until this technology will be mature enough to provide us nice results. Until this, I think it's good to use SBC because they are small, and of course, cloud is also nice, but it is very expensive, and you should transfer as much cost to your customer as you can. Of course, there will be always dilemma to go local, go cloud. Why? There is a simple reason for that, because if you will force customers to send you their data, you can use those data. You can build your own general model, high-end model. You can, you can do whatever you want, because in general models there is no GDPR, because these data are not providing strictly to identify yourself. So you are able to do really nice big data, and mobile devices are really treasury of information. Did you even know that from acceleration sensor from your phone, you are even able to recognize what action are you currently doing? If you are driving a bike, if you are running, if you are sitting, if you are whatever. So your phones contains information about everything about you. So if you are on the bright side of AI development, you would go local. You would try to keep those data on phones to prevent your customers from spreading it over the world and doing like recent Google and Facebook and such other problems. So, anyone has any question to this subject? Because probably some of you disagree with me.
Hello, my name is Taras and I have a question to you. Can you please compare energy use between NVIDIA TX and mobile phones? Can we use NVIDIA with battery, like external device with some BLE Wi-Fi data communication, like external device for video processing?
Okay, that's quite a nice question because I was thinking about this, and NVIDIA TX2 is consuming 14 watts of energy when your mobile at max, as I remember, iPhone X is taking max 3 watts, 3.5. So yes, mobiles are way more efficient in energy usage, but still, I think that in this case, using SBC only as a product, like standing in your home, like in our home automation, or like in a local smart city, which we are going to build soon. I think this is a way more better idea than moving this to the phones, because when you will execute your algorithms on, for example, MPS, cores of iPhone, if you try to run the continuous stream, it would eat your entire battery very, very fast. So I think until we will find out some better way to process those data, or to develop some more efficient batteries, I think until this there's no much choice.
Thanks.
You can also use the one there.
Okay.
Who's gonna be faster?
Okay.
Okay, so I have a hypothetical problem. For instance, if we wanted to recognize some letters on the side, and there are some marks, words on the side, is it able to use the machine learning to retrieve the words?
Words.
Yeah. Retrieve the words, marked words from the side in a picture.
Mark of words from the side of picture, or
Yeah, we have a site in a book.
okay.
Yeah, and we have some marked words. And we want to use some tool to.
Yeah, that's quite simple, because actually in examples of one of the examples is NIST package. So in NIST package you have already provided some tools to recognize specific letters in it, because you are talking about speech to text to image, text to text. Yes.
Yes.
Yes, this is quite easy and nice example that how you can use a pre-trained model on your phone.
So it's able to use only locally on a device?
Yes.
Oh, okay. That's great.
Those models are quite small, because NIST package uses very basic neural networks.
So the user is able to mark some words in a book, and we can just make a photo and
mark.
retrieve it.
I think it's quite easy to because this is a nice example.
Yes.
How we could use it.
Yes, great to know. Thanks.
Okay. Does anyone has some more questions? Do you have some question? No. Okay, so then thank you very much.